Perhaps along with tubes, there's no other component as mysteriously revered in audio engineering as the transformer. And transformers in themselves could be an endless discussion, with all the nuances of the physical properties at play, but I want to focus this video specifically on hysteresis, and how this plays a large part, in my opinion, to the transformer's signature sound. I'll assume some basic understanding of operation, but a quick overview of how an audio transformer works, and feel free to let me know if you'd like to see more comprehensive content on audio transformers too. But okay, transformers transmit audio by means of electromagnetism. In short, like this. A ferrous material is used as a core to wind two wires around. The magnetic property of the core, or flux, and electrical conductivity of the wire creates a magnetic field. And since these two wires are in close enough proximity of each other, their magnetic fields transfer energy. The signal comes in, vibrates this magnetic field, and then this other field picks it up, and then sends the signal down this other wire, without the two wires ever physically touching. This can be handy for isolating signals from electrical interference and hums, or for altering the volume or impedance if we use two different amounts of wire wound on either side. Okay, that's the basics. Now, hysteresis. What is hysteresis exactly? It's basically a type of lag, or delay. It describes the phenomenon of when a physical property is unable to keep up with, or lags behind, the source that's causing it. In this case, the magnetic flux of the core is unable to keep up fully with the input signal, because the changing electromagnetic fields generated leave a backwards or residual impression or influence on the core's magnetic flux, like how if we think of jumping on a trampoline, it soaks in or saturates before expelling the energy fed or inducted by the input signal. And all this still happens rather quickly, so not like an echo, but like a lingering ringing. And it's frequency dependent, and affects the lower frequencies more or longer than the higher frequencies, and provides some level of low frequency distortion that's always present, albeit it can be designed to be very small. So if we try to plot what this might sound like, it will mostly just look like noise, harmonic or phase distortion. But if we think about this more like absorbing and releasing, we could at least theorize some evaporating type of audible component in this, as the source of the noise. And that was the approach I ended up taking in modeling the hysteresis in micro-X-former, to capture some nuance in the hysteresis distortion effect itself, and then some controls to modify it. Character to adjust the brittleness or spongy quality of the effect, similar maybe to a range of different types of materials used in transformer manufacturing, and then the amount on the plus version lets you introduce the desired level of the effect, and this contour control on the plus version lets you soften the onset of the magnetic flux clipping for timing purposes or to let more unaffected transients through. The different models are not attempting to be anything specific, but offer a range of flavors to build your sound around. Sorry for the brief delay, things are moving steadily again. The new QX Comp successor will also be on the way very soon. Notarization is also coming very soon, just a few small details left on that. And AAX version development is underway, so expect news on that soon also.